up, guys? Welcome back to another episode here at Kibbetech. Come check out what we got going on this week. Back here in the machine shop, we got our 5-axis all fired up and running. Got a bunch of tools, got a bunch of tooling from 5th axis. I still can't say it. 5th axis. You can see we got all these faced and drilled, counterbored, tapped. This is for the pull studs for the 5th axis holder up there. So these are 70-75 aluminum. I'm not sure the exact dimensions, but they pretty much end up at like 125 pounds. So that's why I see the engine hoist behind me. It's easy to pick them up, but just leaning them forward into the machine, you know, kind of wrecks your back. So got the engine hoist to load these in. So we do all of them like that, get them faced and set up for the tool holder. And then here is almost done with the first op. So there's some pull studs in here, so we tighten this and that actually holds it down on that platform there. So pretty cool. And on the second op, we're gonna, after we machine and tap all the snout bolts, we'll make a plate that bolts to that, and then it'll have a similar pattern like the 8 holes on there. We'll probably just do 4, and then we'll flip it over and bolt it down that way and clear out the second side. So on this first op right here, it pretty much does about 75% of the spindle. This one isn't done yet, but we gotta do a couple. This is just roughed out right here. So we'll go back to like finish pass like all these. So that's all finished, these are finished. So I gotta work on that bore right there and the bolt holes. But we'll get all the finished passes here and on the other side. And then waiting on another tool. So we're still waiting on another tool to get the bottom bore in that thing. So that's basically a 3/4 bolt for the lower uniball. So I guess I should tell you what this part is. This is a full billet upright. So usually we fabricate all our spindles or uprights out of steel, a bunch of machined and welded parts. So this is just all aluminum, just one piece. It'll have a separate caliper adapter that we'll bolt on, so we'll be able to run any caliper we want. But this is designed specific for our center mount kits, like for the tube chassis truck, the Tundra, the gray truck, and the other bulkheads we have. So we're building 5 sets of these to go with all those bulkheads. And next after this, we'll start doing upper arms and steering. But we just kind of don't want to do the spindles first because they're probably the most intricate part of the center mount as far as machining goes. So we wanted to get used to the machine and used to how to run it and stuff like that. So I figured to dive right in on the most complicated part, and then everything else after this will be a breeze. But we're gonna see where Matt's at on programming the next step of this thing. What's up, Toast?
What's up? What's happening? We got, did you do the rundown yet?
Uh-huh.
Okay, cool.
We're wondering what the next step is.
So we're almost there. Basically, all we have left is we're going to be drilling about 7 inches through the bottom side of the spindle, and shut up. That'll finish the lower control arm mount for the spindle, and then doing a little bit of finishing, surfacing around these corners to make them look nice. Going to finish this face, pocket that guy, finish this face, pocket that guy, and the last thing is to bore this out and then thread mill it for our uniball setup that we have going on. It's not, I mean, it's
top secret.
It'll be nice.
I'm not showing anyone how we're attaching that upper uniball.
Yeah, so
they'll just think it's floating in there.
Yeah, I mean, it's going to be threaded for starters, but there's a few little things going on in there. But yeah, that's pretty much it. And then it's coming out, and then that's pretty much the whole proof, and then we're just going to be running a few more, actually 4 more, sorry. And that's it. So we're pretty close. So I don't know if Troy's going to come back tomorrow and get a full picture of it, but we'll probably do that. Do another time lapse like we did last time.
There you go.
That's pretty much it.
Good job, man.
So this is the complete spindle. That was the last feature that we just finished up. And then using our plug gauge, there's actually 2 sides. There's a go side and a no-go side. It'll show the tolerance for the pitch diameter of the thread, the maximum and the minimum. And basically it has to meet this criteria in order for the go gauge to go. So how this works is we want the go gauge to basically thread in, going, so there it is. So basically we want him to be pretty free. There's about a 5 thou tolerance, so being in the middle of that, you're basically plus or minus 2.5 thou. So that means that it's within tolerance. Now, in order to check the maximum tolerance, this guy, it'll basically bite a little bit, but it doesn't actually go. So this meets the gauge requirements, so that's a good thread. And now we can hold that same tolerance when we're machining the mating misalignment, which is also going to be threaded. So this guy actually has a shoulder where the insert that we're going to be designing actually will sit on for alignment, and then the thread's actually going to hold it, and it has 2 areas to seat on. And basically when we machine the misalignment that goes on there, we'll also do the same tolerances with the class 3 threads. And that's pretty much the last feature. We have a few little different things going on there. I'll blow this guy off. We can check out the B-roll when we roll this thing around.
What was that last part you said?
The B-roll.
No, right before that.
Oh,
So here we have our Pro-Am trophy truck snout. It's a 12-bolt pattern. We did 4 of these holes, or through holes. So I actually run a longer bolt all the way through, nuts on the back, and then these are all threaded because we can't get through bolts on those. So little different step, but this thing's a pretty good vacuum seal on here. It's actually pretty tricky to get lined up because you can push it in and it actually pushes itself back out because of the air in there. So pretty much it's in there right now, but it keeps pushing itself back up. So pretty tight tolerance there. Literally airtight. So
yeah, pretty cool. The biggest thing with this was we wanted to also make sure that all of the mechanical features, meaning the tie rod mounts, the lower control arm mounts, the uniball, the snout, the brake calipers, all of that's machined on the first operation, so that all the true positions and their locations are exactly where they have to be. And then when we turn it around to actually finish doing the material removal, then it's just taking out the excess material. There's no other feature that needs to be done other than just pulling the material out. So that's pretty cool. And the fact that we could do all of that on one shot on the 5-axis is just like astronomical, the amount of time that we've saved on it. So that's pretty cool. So that's pretty much it. We can start pulling it out. And let's see here. So what we did is these are the actual pull studs on the riser block from 5th axis, and these guys will release the part. So we'll go over a little bit how that works. But basically all we have to do is, well, actually it's backwards because of how it's designed. But basically just how you would tighten it, you break these guys loose, and that releases the clamps and the pull studs. And that's pretty much it. Once these guys are loose, it's just a matter of pulling it straight up. But I'd imagine the part still weighs about 30 to 40 pounds, and our finished product will actually be closer to around 19 pounds.
Oh, it's actually a lot lighter than it started out as.
Yeah. So what would you say? What do you think it weighs? 40 pounds maybe?
Probably half.
Yeah, so originally it was about 125 pounds. So Yeah, it's got to be at least 30 to 40 pounds right now. But the size comparison, this versus, you can look at a block down there, it's pretty big. So a lot of material's gone. So this will continue on to the second operation, and we'll kind of go over how we're going to do that. But basically, we're going to be using a second fixture plate that mounts to this surface and then goes back onto those pull studs over there.
Pool studs.
Pull studs.
That's Matt when he's laying out by the pool.
Just pull studding.
Wow.
42 pounds. So that's about
That's crazy.
that's a third. So a third of the way. So 2/3 of material removal so far. We're not even there yet. So quite a bit.
Yeah, you can see how much we got to take off the back.
The fact that we can lift it with your hands instead of a hoist is saying a lot.
Let's see you pick it up. Come on, he's been mountain biking. Watch out.
Oh, this is way lighter, actually. And so now everybody knows I can lift up 40 pounds.
So that's what holds it in.
Yeah, so the backside has obviously these are 10 millimeter bolts that are also countersunk. So the counter bores will actually hold the alignment, and then the threads obviously just for tightening it down.
All right, back here on the 5-axis, we got the last op on the spindles done. So let's come over here and check it out.
Here it is, all done. All of your features. Facing, engraving, basically a lot of material removal. Pretty much everything was surfacing. There's a few areas that were just standard tool paths, like this back face right here. Hit that with a shell mill, and then this was just a standard end mill. Basically everything else was roughed out and then finished up with the surfacing tool paths, a bunch of ball end mills, 3/8 ball end mills and 1/2 inch ball end mills to get it all 100% complete. So the next step is just pulling it out. We have our pull studs, and and basically they're attached to this fixture plate. So we just got to pull this fixture plate off with the three bolts, and then we'll detach the face of the spindle off of that fixture and take a good look at it.
Yeah, so we'll pull that out right now. We'll put it on the table and give you like a before and after of what it, looked like from this op 2 from the beginning to the end. So yeah, let's get that out of there. It's actually pretty light.
Yeah, with the fixture.
Yeah, with the fixture plate.
So that's how it's actually held in there. So we actually have 6 bolts bolted to the spindle, and then we have dowels here, here, and here. So 4 dowels that are actually locating and helping hold the index or true position to that fixture plate. Then these pull studs are obviously screwed in, and that's how that whole setup came.
Yeah, let's pull that off. There we go.
What's it like holding your baby for the first time?
It's actually really light.
Yeah.
I'm gonna go get the scale.
Weights. So that's pretty good. So the computer said it was going to be right around 19.5 pounds. So that's pretty good.
Let's make a set for my truck too, real quick.
Yeah, real quick. So obviously, like the best part, this machine, the fact that we could do this whole entire spindle in 2 operations, that's pretty wild. I mean, there's so many different features on it, so many pockets, between the tie rod mounts, the lower control arm mounts, the upper ball joint mount, the brake tabs and all that stuff. There's just so many features that doing this on a 3-axis mill would be so tedious that you might not even attempt to do it. It's just too much stuff going on. But 2 operations and about 6 hours total runtime. 4 hours on the first op and 2 hours on the second op. So it's pretty good. 6 hours total for 1 spindle complete.
Probably a little less than that on the next ones.
So yeah, that was the initial run. So after it's all set up, we can probably pull some more time out of that. But not bad for the first shot.
Not a lot of people ask, why don't you just do it in 1 op since you have a 5-axis, but to be able to get all these pockets and angles, I don't see being able to do this in 1 op making sense. Because then you would have to have somewhere where you would hold on with a tab, and then you would have this whole spindle hanging off one side, which I don't think we could get these finish passes with holding it that way. So.
Yeah, it's also it's a lot of weight to start off with, 125 pounds to be putting on the machine. And realistically, in order to do it right, we would have to add even a little bit more material, because then we would be parting it off. So it could even be 135 pounds just to try to do that operation in 1 shot. And there would always be one area.
Imagine trying to machine this whole thing with it just being held out like that. It would just shatter and probably shatter way too much and just wouldn't work. So.
Yeah, and with this, at least we can get every side of the spindle. So every single side was machined. There's not one spot that wasn't machined, and there's no deburring. So this is straight out of the machine. There's literally no hard edges. It's all soft to the touch. So that's pretty nice.
Yes, basically this will just go, we'll get our inserts in it, and this will be able to just go straight to a truck, or straight to anodize and then on a truck.
Yeah, and they will be anodized, so that's pretty cool too.
Yeah. You can only imagine what color they're going to be.
Purple.